Okay, so first I'm gonna turn this into orthogonal basis for W, and then I will normalize it, right? By just making them a unit vector. So first I'm gonna start with this. So we first let V1 equals X1, right? That's the first step of a Gram Schmidt. And then, which this will be, okay, it's just this vector, right? 0, 0, 1, 1. And then the second one is, now I'm going to compute the V2, right? And V2 is X2 minus U product V1, V1, V1 times V1, right? Now V2 is going to be, so X2 is 0, 1, 1, 2. And now I do the inner product of X2 with the V1. So X2 inner product with the V1. Okay, so X2, so basically it's inner product of these two, right? Because V1 equals X1. So that's 0. The second one is 0. So 1, 2 is 3, right? So 1 plus 2 is 3. And inner product of V1 with the V1, you just square each component and add it. That's going to be 2. And then times V1, which is 0, 0, 1, 1, right? Okay, now you got this vector. So you got 0, 1, 1, 2. Minus multiply by 3 over 2, we'll get 3 over 2 here, 3 over 2 here, then subtract it, so V2 is going to be 0 here, 1 here, 1 minus 3 over 2 is a half, 2 minus 3 over 2 is a half, right? We get this. Now let's do the V3. So V3 is going to be X3 minus X3 V2, and then V2 times V2 minus X3 V1 divided by V1 times V1, right? That's the third vector in the set. So then we'll just do V3 equal X3 is all ones minus, now I'm going to do, okay, now I'm going to do inner product with X3 with V2, right? So V2 is this guy and X3 is this guy. So do the inner product. The first one is 0. The second one will be 1. And the third one is a half. And the last one is a half. Which this is 1, so you get 2. So 2 over. Now do inner product of V2 with V2, which will be 0 plus 1. So you're squaring it. 1/4 plus another 1/4. Which is 3 over 2. So this is 3 over 2 times V2, which is 0, 1, a half, minus. Now inner product of X3 with the V1, and this is V1, right? So I'm going to do inner product of these two, which first two are 0, and the last two will give you 2, and inner product of V1 with the V1, that's also 2, and then times V1, which is 0, 0, 1, 1. Okay, and this will be now, so 1, 1, 1, 1. Okay, this is just going to be 4 over 3. So multiply by 4 over 3. That's 0. 4 over 3. This will be 2 over 3. And the other one is also 2 over 3. And minus, this will just be 0, 0, 1, 1. Okay, so subtract this 3 vectors. See, this you get 1. This one you get negative 1/3. This one you'll get 1 minus. So ones will cancel. So you get negative 2/3. And then this one, again, 1 will cancel, you get positive 2, negative 2/3. So the last two are the same. Okay, so V3 basically, V3 is going to be 1, negative 1/3, negative 2/3, negative 2/3. So now you got a set, V1, V2, V3, which is an orthogonal set. And what you will do now is just turn this into an orthonormal set by just taking the norm. So this will be V1 divided by V1, V2 divided by normal V2, V3 divided by normal 3 will make this set orthonormal. So I will leave that step. All I have to do is just divide it by norm, so orthonormal set. Gram Schmidt turns a regular linearly independent set, which is a basis of W, into an orthonormal basis for W.